Well, what do you say we take a look around the house, and maybe you can tell us just about how it works?
Great, come on in.
Skeet, I noticed a tube protruding out of the hill here that looks like it leads back to the house. You said this was part of your air conditioning system, I believe.
Well, what it really is my escape hatch for when Bridget gets mad at me. But seriously, it's 200 foot of aluminum culvert, and there's two sections, 100 foot in each section. And there are subterranean tubes, and the function of them is to draw in ambient air temperature or outside air temperature through the tubes to partially dehumidify the air and to cool it with the Earth's temperature. And then that will come up in the crawl space. The tubes are popped up in there like two periscopes, and the air would exit into that area, fill up the lower part of the crawl space, and then as it is warmed, it will go up the double wall in the back of the house and up through the floor of the greenhouse, and then it is finally exhaust through the louvered areas up at the apex of the house. There's 3 of those that will allow the hot air to exhaust to the outside.
So the crawl space being the portion underneath the house.
Right. And
then that cool air loops up around through the house. Is there any particular name for that process?
All right, this is what is known as a thermal chimney. You create heat at the top of the greenhouse, and due to the temperature differentials between the cool air entering the tubes and the hot air at the top of the greenhouse, it creates a thermal siphoning type chimney, somewhat similar to that of a fireplace.
I see. So basically we're taking advantage of the fact that the Earth is naturally cool underground, and that is cooling the air which originates out here in the woods away from the house.
Correct.
All right, now
they flip this button to W for winter. When summer comes, they flip this button to P for preheat, because we preheat or we heat hot water year-round. But our solar space heating bin turns into a cooling bin in the summertime. So they have to flip one little switch.
Now, you're trying to tell me that that's all of the controlling that's necessary by the homeowner is just one switch?
No.
Okay, well, let's get into it. What does he have to do beyond that? Let's suppose it's winter time.
All right, beyond
he switches
that,
it to W for winter, and then what does he do?
All right, he turns those valves by following the instructions of the template that's attached to the valve.
Which is plainly marked.
And it's marked open for summer. So he follows the way that arrow points.
That seems simple.
And then when wintertime comes, he does the same thing on the bottom. It says closed for winter, and he follows that arrow.
So when he turns the switches into the winter or summer mode, then he does the same thing with the valves.
He changes twice a year.
Now, beyond
summer
that,
to winter, he just changes these 3 valves and that one switch.
Okay, and beyond that, what does he have to do?
He's got to know how to work a thermostat that's in the hallway of the house.
And I think just about everybody knows how to do that.
Everyone should know how to work a thermostat.
Okay, now before we take a look at the heat storage bin, tell me about domestic hot water, because I think most people are interested in the energy that's consumed by washing clothes, washing dishes, and so on, especially a family that has children. This is a major energy draw that they have. So tell us about the hot water system in this house.
This is your hot water system.
And this is again coming from the solar collectors.
Comes from the solar collectors. It is heated by the sun.
Mm-hmm.
This 300-gallon tank has a 42-gallon smaller tank inside.
Now inside the main tank.
And it's suspended in the middle of that solar hot water.
All right.
All right, inside the small tank, you have your metered water coming into that small tank and then coming out of that small tank to go to the house. So you're changing the heat from the solar water into the heat that's in the small tank. That's how you heat your household hot water.
Right.
It's a very simple heat transfer. The tank that's inside is very long. It's 4.5 feet long and 16 inches in diameter, which gives you maximum surface space to be transferring solar hot water heat into household hot water heat.
Okay, and it goes from there to where? The domestic hot water heater?
It goes from this inner tank to this tank over here, which is a standard hot water heater. And we don't call that a domestic hot water heater. We call that a backup hot water heater.
Because most of the time, hopefully, you're developing your hot water from the solar collector.
Somewhere between 70 and 90% of the household hot water used will be heated in here.
For the entire year?
For the entire year. You'll get practically 100% efficiency in the hot summer months. You'll drop down to 65 or 70% efficiency in the winter months, because you're not only heating hot water, you're heating the house with the sun.
Well, you know, doesn't look any different than a standard hot water heater, is it?
It is.
Standard hot
That's
water heater?
exactly what it is, a standard hot water heater. It is set on 135 degrees. If the water coming from the inner tank that passes through this standard hot water heater that then goes to the household fixtures, if this water is below 135 degrees, then the standard hot water heater cranks up, fires up, and raises it to 135 degrees.
I see.
Once the sun's water exceeds 135 degrees, this one cuts off. It only operates.
So the system thinks itself. It makes a
itself.
decision as to when it's going to work to your advantage or not. Now, if that's a hot water heater, what is this? Because it looks like a hot water heater, too.
This is a standard hot water heater, and we call it our boiler. Now, what this is backup heat. When we lose the sun, and so therefore the collector plates aren't heating up, then naturally the house is going to have to be heated. But what we do, we set this hot water heater on maximum temperature, which is 165 to 70 degrees, 165 to 170 degrees. Everything is automatic. The homeowner doesn't touch a thing because when the thermostat in the house calls for heat and there's no more heat left in the storage bin, it's a two-stage thermostat which activates a solenoid valve right here, activates this circulating pump. All right, the hot water that's in here at 165 to 170 degrees starts circulating through 200 linear feet of thin coil tubing.
Which is located where?
Above the solar bin in the storage area.
I see.
So the air passing through the solar bin has to pass by the thin tubing.
All right, now we'll take a look at that in a minute, but what you're telling me is that whereas many solar houses in the United States that have to have, in most cases, a backup furnace system, and indeed do have a furnace, that this is your furnace.
This is a furnace, and it's adequately rated by the United States government.
And it's just really a hot water heater.
It's a 40-gallon glass-lined hot water heater set on maximum temperature. And this small water heater heats the whole house.
That's fantastic. Let's go look at the collection apparatus and see what we have. Gene, we're looking into the storage bin, and like you said, we see quite a bit of rocks in there. How about explaining just how this solar storage bin works?
Bill, the 1,600-gallon tank is surrounded by these rocks. We have a large blower that blows air at the bottom of the storage bin, forcing it into the solar bin, and the air is forced and sifts up through the rock. The heat from the tank is transmitted into the rock, so you have not only the hot rocks or the warm rocks around the tank itself is hot, and as the air is forced around the tank and through the rock, it then passes on into the house with its heat. The air picks up the heat from this to go into the house.
All right, now I noticed at the top of the storage tank we have some, looks like some fin tubes, a lot of copper pipe with some fins on it. What part of the system is this?
Bill, when I mentioned to you about the backup heat, and I call that hot water heater the boiler, when the boiler cuts on automatically, it's done through the thermostat. The hot water from the boiler, which hits 170 to 200 degrees, or averages around 170 degrees, will circulate through this fin tubing. Well, as the air passes through the solar bin and there's no more stored heat, it has to pass this fin tubing before it goes into the house. And as the air passes the fin tubing, it extracts the heat off the tip of the fins and distributes it to the inside of the house.
All right, now, Gene, we've talked about how this solar storage bin collects and saves heat for the days that we may not have sun or during the evening. But I think you also mentioned earlier that this also stores cool as well as heat. Tell me about the air conditioning system on this house and just how the storage tank plays a part in that.
After the homeowner has disconnected the bin from the hot water heater tank, the preheater tank, it becomes a cooling bin. And the compressor is a standard electric compressor with an A coil that sits on the shelf that you can't see. Actually, the air is moved through the return air chase, passes through the coil, or the evaporator, as the trade calls it, cools the air and is forced into the storage bin just like the heat is forced into the storage bin with a large blower. The coil will chill down the rock and the water and then pass it on into the air. As the air passes the rock in the tank that's been chilled down, it'll pass on into the house and cool the house.
Now, normally the homeowner during the very hottest months of the summer would be making cool air, I think, in the evening time because it would be cooler in the evening than during the day and thus more efficient. Is that the way it works?
That's right. In our control panel, there's a time clock. and it keeps the compressor cut off except during the evening hours. We're hoping that Georgia Power, for instance, will offer off-peak metering, which means they can chill and cool down their storage bin during the off-peak hours. The time clock cuts the system down, and then the blower works off the thermostat, will continually send cool air through the house during the hot day without the use of the compressor or the evaporator working.
So this storage tank is really one of the key elements to a lot of the savings in this house.
That 1,600 gallons of water is really the key element, because the sun heats the water very easily. It's a little bit harder to cool a house than it is to heat a house. But as your evaporator coil chills the water down, it's a mass of water that stays cool for a long period of time, and that's why you can run your air conditioning without actually having your condensing unit on.
You naturally